Okay, everyone, if you're looking for a talk on dictionaries, that won't be happening. Instead, we have a talk from Nick Acosta, who has said that he will not be taking questions at the end. So let's all welcome Nick. Thank you.
Hi, thank you. Can you all hear me? Excellent. My name is Nick Acosta, and I work at the IBM Data Science community. And today I'll be talking about a way that you can select a deep learning framework to develop, build out, and serve neural network models, and how to do so using a way that is involving deep learning. So as part of the IBM Data Science community, I work with developers that are often interested in getting started in AI and machine learning. And I'll talk to them about how they can do so using open source software. And then I also use open source software to perform AI and machine learning on developers as well. So something that I'm frequently come across in my discussion with developers is I'm often asked the question that you see on the screen here. Which deep learning framework should I be using for neural network development? So this is a question that I'm often asked in discussion. And then in analysis of developers, I found that this is an important question because it's not something that changes very often. In my analysis, I found if you use a deep learning framework and you get comfortable with it, you tend not to switch. So we can just take a quick poll. Is there anyone that uses a deep learning framework to a point where they have enough experience where they feel comfortable, solving problems with maybe TensorFlow or something like that? So a few people. Now, of those people, have you developed in a deep learning framework and then switched to another one and now you feel comfortable in that one as well? So we've got a single hand, right? So that's something that does happen, but it's not very frequent. So not only a question that I'm asked often, but something that I think is pretty important. It's not a question that's just asked of me. It's a popular topic on the internet. You can search around and it's pretty easy to find a wealth of content on this area. The content usually falls into 3 different camps. So there will be maybe a historical overview providing some context of how deep learning frameworks came about, as you can see here from this InfoWorld article. There can be an explanation of differences, what makes one different than the other. You can see this author in KD Nuggets kind of started to explain some of those differences. Or there will be an advisory of preferences that we see here through posts by Udacity, through Medium about TensorFlow, PyTorch, the force is strong with which one. So although the content typically has those 3 distinct features, some can be a combination of the 3, and most end up having some sort of advisory voice. All 3 examples here touch at least somewhat on giving some advice as far as which one you should start with, which one you should try out. If you program this way, maybe try this one, things like that. But what I've seen and experienced is that lends itself to subjectivity and anecdotal evidence, like TensorFlow works for me, so it'll work for you type of thing. And that's exactly what we're trying to get away from with the field of deep learning, right? With deep learning, we're trying to take in all the information that's available to us and let something make a decision based upon that data, maybe not because of an opinion or something like that, right? And these articles also lend themselves to the current state of deep learning frameworks, right? So I can suggest something to you now, but the field of deep learning, I promise you, will drastically change in the coming years, right? And the frameworks that support deep learning are going to change probably even more drastically. So a very new field, the frameworks that support it are even newer. So I think that is, my advice would be to start with a framework that is chosen for you via deep learning. So that's what I'll be talking about today. So going through the agenda for the rest of this half hour, we're currently on the introduction, part 1. We walk through some things that you see as far as deep learning advice, content-wise. Going on the agenda now. Part 2, we'll briefly discuss deep learning frameworks, what they are and some examples of them. Part 3, we'll be doing deep learning on these deep learning frameworks. So to do so, we need data and models, and that will be parts 3 and 4. Talk about how I collected data for this project, the models that I chose to model against it, things like that. Before part 5, wrapping up with some resources for you to maybe try out yourself or take with you or to consider. So what is a deep learning framework? It allows for the easy construction of neural networks. And I have easy in a different color there because it's like a very relative term in this sentence. I think it's generally easier to use a deep learning framework and build out a neural network than it is to just use like pure Python to do so. Some of the reasons why are they abstract away some of the lowest level details that you have in a neural network model. So all modern deep learning frameworks do something called automatic differentiation, which can be hard to keep track of how your neural network changes and how the loss function and derivatives change. So that's something that they all take care of for you now, which I appreciate. Another thing that they do is standardize commonly used neural network concepts from maybe components of a network. So if I use TensorFlow and I have a dropout layer in my model and you use TensorFlow and have a dropout layer in your model, they're going to be the same thing, right? Or you can load in entirely pre-trained models, which is also very convenient. And thirdly, deep learning frameworks provide tooling for deployments on various hardware configurations, which is important because modern neural networks can really benefit from running on non-standard hardware like GPUs. So it allows you to, as a maybe machine learning developer or data scientist, focus your time on building out models, and you don't have to have that like DevOps experience in how do I land this model across maybe multiple machines, things like that. An example of a deep learning framework is TensorFlow. TensorFlow came out of Google via the Google Brain team in like around late 2015. So what we saw as far as people in this audience as it relates to Python is it was built really for distributed computing. The Google Brain team had a Google amount of compute to really access and train their models on, right? But didn't really have the modern, at the time, machine learning frameworks, weren't able to really support and take advantage of having just so much compute at their disposal. So TensorFlow is built for them for that reason, right? To be able to land a neural network across multiple machines. And early versions of TensorFlow, you could really feel that it was built out by maybe like DevOps developers where it was very not Pythonic, I'll just say, right? So, which has been a problem because Python developers use TensorFlow way more often than any other development community. So you've seen that really be addressed and with current versions of TensorFlow, and that's something that I have been looking forward to and have really enjoyed recently. Anyway, it has gone from that deep learning framework to now a whole ecosystem where you can see not just for Python development, but you can also use JavaScript. You can use Swift, things like that. You can not only build out neural networks, but do things with data. You can serve your models, things like that. So it's really blown up quite extensively. So a case study, here's something that's in that data set that I'll be going in a couple of slides. Here you can see someone's using TensorFlow to generate Pokemon cards. So they take in a bunch of images of Pokemon cards. Through TensorFlow, they're able to feed it through something called a GAN, and it have the neural network generate its own Pokemon card images. So you can see the one on the left there can do a move called Mad Voice, where the one on the right here, Swid Mono, can do a move called Skeet Backer, right? And those are all generated through a model in TensorFlow. They're not like a real Pokemon. And my slides, I'll link to them at the end. And this GitHub project is hyperlinked on this image, so you can check it out if you would like. Another example of a deep learning framework is PyTorch, which is coming out of Facebook. You can see a lot of similarities here. It was shortly after TensorFlow. It's just a Python implementation of Torch. Is how it started, and Torch was a scientific computing and machine learning library. So a lot of similarities there, but kind of differences about how it got started, some of the features, especially maybe like last year and previous versions of both PyTorch and TensorFlow, they were used for different reasons, things like that. An example of someone using PyTorch is this Pokemon GAN, right? So something very similar. They took images of these Pokemon on the left here called sprites, which are just like the official image of a particular Pokemon, fed them through a GAN, and were able to generate their own Pokemon using PyTorch in a neural network on the right. So I've got a lot of code on this slide, so you'll just have to take my word for it that this is, the TensorFlow on the project on the left, the PyTorch project on the right, both doing very similar things, right? Generating new monsters, doing it very similar ways through the same sort of model, but you do start to see distinct differences even in these projects and how they go about developing it, how they go about collecting their data set, right? There's definitely some very apparent differences between these frameworks, which becomes very easily apparent as you do it at scale, right? Instead of those two examples, we'll look at a deep learning scale example where there's many data involved. So this will be part 3, talking about the data that I've collected to kind of help you choose a deep learning framework in a deep learning centric way. So to do this deep learning framework, we're just going to do classic supervised text classification. And to do so, we need classes, of which I have 2. And I'll link to this data, tell you about the process of collecting examples for each of these classes, and then give you access to the data set yourself that you can play around with. So it's pretty easily extensible to add your own examples or add a different deep learning framework, things like that. I was able to build out this data set in Python through PyGitHub. PyGitHub is a Python implementation of GitHub's API. So just crafting some queries that were looking for repos that referenced either TensorFlow or PyTorch. And then I would recursively crawl through all of these repos and grab any notebook that was in these repos and just pull them down. This is what you get from PyGitHub, just like a raw Jupyter Notebook file. I would then parse out those notebook files for just the code. So and if you're familiar with a notebook, you can embed media in there. You can have markdown. So I scraped all that out. I just got the code, which is what you see at the top here. This is an example of code for the notebook that I built for this project. And then I just label it based upon the search query that it came from. So this notebook uses TensorFlow, so I just label it as such. So you just get like a big 2-dimensional array, one thing with code, another thing with that's labeled as TensorFlow. Then on the bottom half of the screen, you can see I have removed some things. I don't know if you can see my cursor here. Yeah, so I've removed a couple 1-character words like I and 2. I removed some things that would be kind of, I don't know what the right would be, like, I don't want to say cheating, but like if a code had the word TensorFlow in it, I don't want to send that to a classifier. That's kind of like a dead giveaway that they're using TensorFlow. So I remove words like that, remove single character words, cool things like that. So I did this 3 times, and there are some stats on kind of the first state and the current state of this data set. So the difference between sets 1 and sets 2 and 3 is in sets 2 and 3, I got a lot more comfortable, I think, with the GitHub APIs, like query interface and how to really get repos back. So I think sets 2 and 3 are a lot better representation of the GitHub universe as far as it relates to deep learning frameworks. You can see that there's a split of about 57 to 59 to 40 or so, just over 40. So it's predominantly TensorFlow examples that we see here, but much more so than I realized. Like there's a lot of people using PyTorch, which is good to see that diversity between these deep learning frameworks. I think you'd think, or at least I think personally, I thought it was a lot heavier skewed in one direction. You can see the number of repos and notebooks that were collected in this data set. And then something of note that I think as the number of notebooks almost double and the number of total words almost double as well, you can see that the number of unique words in these data sets kind of grow at a much slower rate, which is just more to the fact that there is a finite dictionary that we use for deep learning development, right? So after collecting that data set, there's a little bit of data pre-processing that you have to do to feed them through a neural network. There's 2 things that at least I know of that are beneficial to do if you're doing text classification. 2 approaches, a bag of words approach where for each element in my data set, all of these notebooks, all 9,000 of them, you go through in every word that occurs, so all 60,000 words, and you just count and have a 50 or 60,000 feature vector, right, of every word and for every notebook, just rack it up and then send it through a neural network. So this is good because it's a full representation of your data, like nothing's missing, nothing's out of the ordinary, but it can become extremely, extremely sparse. Like in that TensorFlow example that we saw with the Pokemon cards, and that move that the Pokemon card could do, skeet backer, each of those words would become a column in my data set, and I'm very, very comfortable with the assumption that that doesn't occur anywhere else in my data set, right? So that can be like data that's very sparse, and that can be difficult for some neural networks to manage. A way to alleviate that problem is via text embedding. So that translates your very high dimensional text space into a much lower dimensional, more dense feature space. So that, by that, it increases the number of hyperparameters that are in your model, which are numbers that you have to determine and set for your neural network to train. A good thing about that is there are cloud service providers such as IBM and others that allow you to automatically search through and optimize a hyperparameter search space. So that's not too big of a problem now, but it's something to be aware of. There are common predefined text embeddings, like the most popular one is word2vec. But those embed semantics in on their feature vector as far as like the placement of various columns and where they are relative to each other, that I didn't think was appropriate for these models. But that is okay because you can train your own text embeddings via deep learning framework, right? So TensorFlow through Keras, you can call like tensorflow.keras.text.embedding. And that's just an API call that you stick as the first model or layer in your model, and it will train one for you, right? So pretty easy stuff. Using those two methods of preparation, I built out a number of different models. There were 4 that I'll be presenting today. I took the same model here and did it both ways using that bag of words approach and a text embedding approach. And then this text embedding, my first exposure to it was through a paper out of New York University, NYU. I think around 2017, they became quite popular because of something called the text CNN. So you can look for that. It should be pretty easy to find. Where that was my first exposure to text embeddings and also one-dimensional convolutional network layers. So that's pretty interesting, and I was able to kind of steal that architecture and model it for this talk. And I did so using some popular, mixed what they did in that paper with some popular image classifiers like LayNet and VGG, kind of very easily created my own models, which you can take a look at for yourself. I'll be linking to them at the end here. But just a number of different ways to build out models here using that embedding that I mentioned. So some results. Here you can see at the top left is using that bag of words approach compared to doing the same network, only using that text embedding layer instead of that very large, 60,000 feature vector for each instance of my data. And that really makes a difference. You can see that there's 57 million parameters for my neural network to learn in the first example versus only 5 million in the second example. So an order of magnitude less parameters to train, which really helped with the training time. So a single epoch took 420 seconds, which is 7 minutes to train versus less than a minute. So an order of magnitude quicker, which was very beneficial for me because it took about 20 epochs before I really stopped seeing improvements in accuracy. So 20 doing something that takes 7 minutes 20 times is like over 2 hours. So yeah, definitely the way to go as far as using that embedding layer, because you can see the accuracy actually went up as well as a result of using less parameters. Then you can see I use those common image classifier architectures, VGG and LayNet here on the right, where I think that ended up being a good mix of, especially using, kind of adopting LayNet architecture to text classification was a good mix of a model that I thought was very accurate. It was a model that used trained the smallest number of parameters out of all of these models and had a pretty quick training time, so I was happy with that. One metric that I have here at the bottom, if you can see it in the way back, is called Fleece's kappa. So that is a metric that assesses the agreeability of different classifiers. So it goes from 0 to 1. So a 0.87 is very, very high. A 0 would be they never classify the same data the same way. A 1 would be they always classify the same data the same way. And I think that that points to, in this instance, if you're using it on neural networks, I interpret that as being, if it's very high, I interpret that being just a function of the data set. It's very easy to classify this data set, in my opinion, and the Fleece's kappa, the kappa coefficient here, really reflects that from it being so high. So I'll be linking to this data set at the end of my talk here in a couple slides. And if you're interested in, maybe you haven't done text classification before, you're looking for a data set to get started, this one you can really throw pretty much any classifier at it, and it will perform generally well. All right, so that's what I have so far as an introduction to deep learning frameworks, some data that I've collected on examples between them, some models that were built out to be able to predict based upon code, which kind of deep learning framework you belong to. So now I'd like to share some resources to where you can kind of use these yourself. So here I have a Flask application that couldn't be more lightweight. Like, I'm not a web developer, so I apologize for the aesthetics of this website, but it is built in Flask, which I hope that you appreciate. And you can take this, and this is at dlclassifier.mybluemix.net, and you can upload an example of your own code as long as it's in a notebook file format. And what I'll be doing is scraping your code or scraping your notebook for code and sending it to those classifiers that I just talked about. And you'll be able to use some of your own code examples and maybe see which classifier your code most closely matches. Right, so you can see I had a lot of TensorFlow in this code, and I'm very heavily leaning towards that camp. I think that that is, very reflective in my coding style and kind of the problems that I deal with. Really made sense to me. So that, I don't know if that's something that you can see. Let me blow up. So this is what you'll be getting back. So I just used a service that collapses a TensorFlow model into an API. I stuck that in a Flask application, and you can try it out for yourself. Don't break it. It's probably easy to break. Again, I'm not a web developer, but go ahead and try that out. I have had a lot more success if I'm using one of my own notebooks. If that button in Jupyter where you can clear your output, I do that, and then I send it, and it ends up being at least twice as fast if I don't have a bunch of print statements, things like that. If you would like access to the code that I built out that Flask application for, there's 2 lines that will be in this directory. Here, this is my GitHub page, and under the repo DL classifiers, this information. You can see that there is, this whole data set is available to you as a NumPy array. Right, so you can pull that into Python, and again, really whatever classifier you would like. I've seen it work pretty well, so I think it's a good place to get started. Again, that link to just try out the end result and get some predictions for yourself. I do have these slides available as well here in this PyCon UK folder, where you can see some of the other projects that I've referenced are hyperlinked there, things like that. So this is some content and other projects that I work on that I will present in the discuss in the IBM data science community, which I think is a great place to see what others are working on. And also, I would love to see some people in the audience, talk about what they're working on and maybe some problems or successes they've had. Is a place where I've had success, just discussing other, like-minded developers. And one last thing I'd like to touch on is call for code. So call for code is challenged through IBM and some of its partners like the Red Cross and the United Nations. where we're challenging developers to help others in adverse situations. So this year's theme was to use technology to combat mental, health issues that can arise in the presence of natural disasters. And next month, we'll be rewarding 2019's winner for a call for code. And the winner gets a $200,000 cash prize. They get access to IBM's, an extensive partnership ecosystem, like we have last year's winners working with like the local governments of Puerto Rico and with the American Red Cross and things like that too. We really want to not just give you money to help your idea, but we really want to give you the resources to get your technology that can help others in the hands of those that need help. So I was lucky enough to be able to judge some of this year's Call for Code contestants. We do have 5 European finalists this year. It's, to my knowledge, most of them are hailing from Spain, so I didn't really see a UK representation that I was super thrilled with. So I would love, if you have an idea that can help others, this is a great opportunity to get that idea out and get exposure and some help with it. So something to consider, again, along with the IBM data science community and this project as well. So with that, I appreciate you, listening to this talk, and especially, those at PyCon UK. Thanks for having me.
Yeah, thank you. I appreciate it.
Okay, thanks everyone, and thank you, Nick, for a very interesting talk. So there's going to be a coffee break now. The dictionaries talk, we have managed to reschedule that for 12:30 in room D. The schedule on the website is up to date. So thank you very much. Enjoy your coffee.